A box has a mass of 8.00 kilograms, so there's a known. Knowing that the gravitational field strength on Earth is 9.8 newtons per kilogram, calculate the force of gravity on the box. So what we do not know is the force of gravity. So that's Fg. Alright, so we know mass. That's the 8.00 kilogram. And we know gravitational field strength of G is 9.8 newtons per kilogram. This is so hard to write with. Okay, so the equation that we're going to use is mg. So we're going to take 8 times 9.8, and that will give us 78.4, and we're left with newtons. So anytime we're looking for a force, we will look for newtons. So there's our first example. In our second example, the Earth exerts a gravitational force of 500 newtons on Amy. What is Amy's mass in kilograms? So what we want to know is Amy's mass. So our unknown is m. So we know Fg, because that's the 500 newtons. We saw that newtons there, and that told us it's the force. And again, because it's the constant, the gravitational field strength on Earth is 9.8 newtons per kilogram. So those are our two knowns, our givens. So the formula that we will use is going to be Fg divided by the gravitational field strength. So the force of gravity divided by gravitational field strength. So that would be 500 divided by 9.8. When we do this, we're going to get a 51.0204 ... But we're going to cut this off at the second decimal, or 2 places past the decimal. So our final answer would be 51.02, and now since we're looking for mass, it'd be kilograms for our unit. In our third example, a potted plant has a mass of 2.2 kilograms. If the plant weighs 19.6 newtons, and newtons should tell us, oh, we're looking at force on Venus. What is Venus's gravitational field strength? So what we don't know is the gravitational field strength. So we're looking for the lower g. We do know mass. It's 2 point, there's a point there somewhere, 2.2 kilograms. And then we know the force of gravity, which is 19.6 newtons. Our equation then, because we're looking for the gravitational field strength, is the force of gravity divided by mass. So we have 19.6 divided by 2.2, and again that gives us a really long number, 8.90909 ... And we want to cut it off at 2 places past the decimal. So we end up with 8.91 newtons per kilogram as our answer. And there you have our 3 examples. If you have any questions, don't hesitate to ask me in class.